So now we're going to talk about the method to determine if the turning point is a maximum or a minimum. Okay. So we need to recall, I'm going to repeat that again, that your first derivative, okay, the first derivative, or like, this first derivative, it can be dy by dx, or it can be f dash of x. This first derivative is used, first of all, it gives us the gradient of the tangent or the curve, okay? And secondly, it helps us to find the x coordinate or the coordinates of the stationary points B, we call them, or we call them the turning points. You can call them the maximum point. You can call them the minimum point. And even they are also called the vertex of the curve. There are so many names for this stationary point, okay? This stationary point is basically like if you have an upward parabola, okay? So here is that stationary point. So your first derivative is going to help you to find this the coordinate, the x coordinate of the stationary point. For that purpose, you put that dy by dx equal to 0. And why do you put that equal to 0? Because you know that the tangent at the stationary point is always a horizontal line. And a horizontal line's gradient is equal to 0. Okay. So that is what you people already have done. Now we are going to talk about the use of the second derivative. The second derivative, you will be finding the second derivative, and the second derivative will help you to determine the nature of this turning point, okay? So the second derivative, let me write it down here, and you can write this again. The more you write it, there's a greater chance that you remember this, okay? The second derivative, or which is called d2y by dx square, or you can call this f dash of x. So this is used to determine the nature of a turning point, a stationary point, okay? And you will be noting down in your notes here that if d2y by dx square is positive, okay? For example, you found after putting dy by dx equal to 0, suppose you had x minus 2, that was your dy by dx, and that was equal to 0. This gave you x equal to 2, okay? And then you substituted that x into this, and if this happened to be positive, the stationary point will be a minimum point. ये उल्ट होता है. If it is positive, it will be minimum. And if your second derivative happens to be negative after you have substituted that value, okay, then the stationary point will be a maximum point, okay? And this minimum point can also be called minima, okay? But maze ke names are yahan pe, minima. And this maximum point can also be called a maxima, okay? So you have a minima if your second derivative is positive. You will have a maximum if your second derivative is negative. Okay, now let's try some questions over from here. In this first question of this exercise 8b, it says find the coordinates of the stationary points. So this is the first part. You will have to find the coordinates of the stationary point, okay? And then it says determine the nature, okay? So I'm not going to take you people to sketching this. So don't do that sketching. We're just going to focus on the first derivative, the second derivative, and determining the nature of that point, okay? So Let's do this first part, okay? We have y equal to x square minus 4x plus 8. Now, the first task is to find the coordinates of the stationary point. Please remember, for the coordinates of the stationary point, you find the first derivative and you put that equal to 0, okay? So that is your first task. You will be finding the dy by dx, that is 2x minus 4, and you straight away put that equal to 0. That is x equal to 2. You put that back into the original equation so that you can find the corresponding y coordinate. That is 4 minus 8 plus 8, and that is going to be 4. So this is your stationary point on the curve. Okay? Now we have to see that if this point was a maximum point or a minimum point. For that purpose, you will find the second derivative. The second derivative is 2. You didn't have to substitute the value of x into it. This happened to be a number. So this is, we can simply say, look, this is positive. The second derivative is positive. Therefore, 2 comma 4 is a minimum. Yeah, it is a minimum point. Whatever you want to say. It is a minimum. Okay? Let me do this C part now. Okay, C part. I'll be doing it here. Okay, so we have y equal to x cube minus 12x plus 6. So first task is to find the coordinates of the stationary point. So I need to find the dy by dx. That is 3x squared minus 12. And I'll put that equal to 0. Okay. So this is going to give me x squared equal to 4 and x is equal to plus minus 2. So guys, this time we have two stationary points. There are two turning points. So you're getting two values of x. Okay. So let's find the second derivative quickly, and then we'll be finding the point and the nature, determining the nature together, okay? So let's find the second derivative, d2y by dx squared. That is going to be 6x. That is equal to 6x, okay? So now I would say at x equal to minus 2. My y is minus 8 plus 24 plus 6. This is going to give me 30, this is 22. And d2y by dx squared, when I put minus 2 here, this is going to be minus 12. And this is negative. This means minus 2 comma 22 is a maximum point. That is a maximum point. Okay, then I would say at x equal to 2, I will first of all find the y coordinate. That is going to be 8 minus 24 plus 6, and that is minus 10. And I would see that what is this d2y by dx squared? We don't actually need its value. We only need to know that if it is positive or negative, okay? So that is going to be 12. So this is positive. Therefore, 2 comma minus 10 is a minimum point or a minima, okay? So this is all the working that you guys need to do. Okay? If you look at these questions of different parts of this question number 2, the story is same, bacho. You find dy by dx equal to 0, you get the x coordinates, okay? You get the x coordinates. You find the second derivative, okay? You use your x, you put your x into y and then x into this d2y by dx square. Here you will be finding the corresponding y coordinate, okay? And this would tell you the nature of that turning point. The rest is your ability, your skills on the differentiation, how good you people are at differentiating these given expressions. Okay? Should I do any part from question number 1, 2, or 3, 4? Hmm? Okay, I think you people are fine. It is your time for you people to practice from here, okay?